Okay, question 8 is another stats question, and it's a bit of coding. So in this it says data relating to the lifetime to the nearest hour of a random sample of 200 light bulbs from the production line of a manufacturer is summarized in a group frequency table. So there's some more information there about midpoints and how the mean was calculated, things like that. But we've been given a code to use. We've also been given some information here. So the sum of Fy and the sum of Fy squared. Another useful piece of information will probably be the sum of the frequencies, which is the total number in the sample. So that's going to be another piece of useful information. In this question it says calculate estimates of the mean and the standard deviation. So I've put the standard deviation formula up because it's in the formula book, and how this compares with a grouped frequency table means we just put F's in there basically. So it's going to be, for a standard deviation, the sum of F times X squared, and N is your sample size, so that's the sum of the frequencies, minus X bar. X bar is the mean. So to calculate the mean, I need to do the sum of F times X over the sum of F. So I could rewrite it like that. And that's all squared. So that's what I've been given. Now I need to use the code in order to find the mean and standard deviation of the lifetime of the bulbs, which is X. So X is the data from the table. So I'm actually going to use the code to work out the coded mean and the coded standard deviation. So let's have a look at mean. If I was to find the mean of Y, that would be the mean of X, and if I add or subtract numbers to my data, that will affect the mean, and if I multiply and divide numbers to my data, that also affects the mean. So that's what the code would look like for the mean. If I look at standard deviation, if I add or subtract numbers to the mean, that has no effect on your standard deviation, but if I multiply and divide, it does. So that's how that gets affected. So I could do a bit of rearranging and say, in order then to find the mean of X, I can just rearrange this, and it's going to be 2.5 Y bar plus 755. So that's going to be my code to find the mean of X. Likewise, I can find the standard deviation of X by doing 2.5 times the standard deviation of Y. So I've just rearranged these to get a coding formula for mean and standard deviation. Now I want to find the mean and the standard deviation of X, so I first need to find the mean and standard deviation of Y. Okay, so the mean of Y is going to be the sum of F times Y over the sum of F. And I've been given these values in the question. Sum of F times Y is minus 467. Sum of the frequencies is 200. So that comes out to be minus 2.335. So I can go ahead and put that in the coding formula now. The sum of X, the mean of X, which is X bar, is going to be 2.5 times Y bar, which is this, plus 755. So X bar is 749.1625. I'll just write down everything there. I can do the same for the standard deviation now. So in order to find the standard deviation of x, I need to find the standard deviation of y, and I use the standard deviation formula. So that's going to be sum of fy squared over the sum of f minus sum of fy over sum of f all squared. So that is using the numbers that I've given. I've been given sum of fy squared, so I don't have to work that out. It's 9179 over the sum of f, which is 200, minus sum of f times y over 200 squared, square root that, and I end up with 6.3594, etc. So I can put that number into my coding formula over here. Sum of x then is 2.5 times that number, 63594. So that gives me the standard deviation of x, which is 15.8986, etc. Okay, that's question 8.